Okay, so now we're going to be looking at the last section having to do with probability. And it goes back to actually something we looked at the very beginning of our work with probability. It looks at outcomes, and it looks at sets of outcomes, and it looks at them visually laid out in what they're calling sample spaces. So we have already seen some things like this. We're going to go through a solution to this problem, 8n, number 1, that deals with these tetrahedral dice that are shaped like a pyramid with a triangle on each side. And each of them is capable of rolling only one number from 1 to 4. But before we do that, I want to go back and look at the outcome set we did for regular dice. Here's the regular dice outcome set, 36 different outcomes. And that's what I just looked at in the last video that had to do with independence. So really when we're looking at tetrahedral dice, it cuts it down. There's not 6 sides, there's only 4 sides. And so our sample space now is a lot smaller. This sample space only has 4 by 4 or 16 different outcomes. And so it's a little bit unusual, but it's actually easier to deal with than 36 different outcomes. So if we look at the problem, the first step is it says it wants to know where the probability that the number on the red die is greater than the number on the blue one. Okay. Well, okay, I said green and red rather than blue and red, but that's just because that's the last one I had for the 6-sided dice. So now if we're going to find the probability that the number on the red die is greater, okay? So here's the red die outcomes from 1 to 4. Okay, so in each of these outcomes, if the number on the right, which is the red die, is greater than the one on the left, that counts as our event. Okay, so 4 is greater than 1, that's an outcome in our set. 3 is greater than 1, 2 is greater than 1, but 1's not greater than 1, so that one's not in the set. These 3 are. 4 is greater than 2, 3 is greater than 2. 2 is not greater than 2, it's equal to 2, so that one doesn't count. And that's the last one there. So these 6 outcomes, all collectively looped together, make up my event. So if I, instead of circling the individual outcomes, I circle them all as one big event space or set, then that, like I said, kind of goes back to the beginning when we look at the population of a set divided by the population of the entire universal set. So 1, 2, 3, 4, 5, 6 outcomes in the event. And as we said before, it's 4 by 4, so there's 16 total outcomes. This is part A. So 6 out of 16 is 3 out of 8. Okay, so 3/8 is the probability that the red die will actually be the greater of the 2 die. Okay. Now let's erase that event and go on to the next one. All right, we'll leave that answer up there. For part B, in part B, we're looking at where the difference of the dice is equal to 1. Okay, so the numbers, you take one number minus the other, and no matter which one, whether it's positive or negative, isn't going to be a concern. You just want the difference to be exactly 1. Okay. So let's see, let's figure it out. 4 and 1 differ by 3, that doesn't count. But 2 and 1, that counts. 2 and 1 differ by 1. Okay, 1 and 1, that would be a difference of 0. Well, if 2 and 1 differ by 1, 1 and 2 also differ by 1. We're not going to say one's negative 1. We're just going to say they both differ by 1. 1 and 3, now 1 and 4, those are out. But now let's see here, 3 and 4, those differ by 1, and so do 4 and 3. Okay, so now let's see some sort of pattern here. Sure, there it is. 3 and 2 differ by 1, and so do 2 and 3. So those 6 outcomes are the only ones that fit my event. So once again, we have 6 over 16, and that equals 3/8. This isn't a set I can easily draw one nice circle around. I can sort of draw a horseshoe-shaped circle around it, but it doesn't look very good. You know, these outcomes collectively then, these boxed ones, those make the event where the difference in the numbers is equal to 1. All right, let's look at the third part. Part C. What does C ask? C asks, what's the probability the red die shows an odd number and the other one shows an even number? So if the red is odd, there's 2 ways that can happen. It could be 1 or 3. So these are odd. These outcomes are not in my set. These might be or might not be, because at least the red part is odd. Now we look for where the red is odd and the other one's even. So a red is odd and this one's even there. The red is odd and this one's even there. This is the other one where the red is odd and the other die is even. That's it. There's only those 4 outcomes, so that's only 4 out of the 16, or 1/4, is the probability that that's going to occur. All right, you notice now that I got a little cramped for room, I turned my fractions into slantways fractions rather than verticals. Vertical is better to write them, but when you run out of room, then you have to squeeze them a little bit. Let's look at the last one. The sum of the numbers on the dice is prime. The sum is prime. Okay. Well, let's just start at one corner and work through them. If here's the sum is 2, 2 is prime. So let's underline that one. Here the sum is 3, 3 is prime. 4, no, that's not prime, but 5 is prime. Okay, so we have 3 of them in the top row. Likewise, I can go down the same way. 1 and 1 is 2. 2 and 1 is 3. 3 and 1 is 4, that's not prime, but 4 and 1 is 5, and that's prime. So it doesn't matter which one's which. Okay, 2 plus 2 is 4, that's not prime, but 2 plus 3 is 5, and it is. 6, not prime. I think we're done there. Oh, let's see, we've got a parallel one down here. 3 and 2, 2 and 3 have the same properties. So whenever we find an outcome that's in the event, if I just change the order, I get one of the other outcomes. 4 and 2 is 6, just like 2 and 4 is. 3 and 3 are 6, that's not prime either. 4 and 3, that's 7, that's prime, and so is 3 and 4. And then the last one to consider, 4 and 4. 4 and 4 is 8, 8's not prime, so I'm done. Count them up. 1, 2, 3, 4, 5, 6, 7, 8. 8 out of 16, that's 1/2. Half of the outcomes involve the sum of a prime number. Okay, so this is the outcome space. We've already done problems using this concept earlier, but all of the problems in this section, this is problem number 1 in 8N, it's page 365, and all of them will involve writing out outcomes in an array like this, or thinking about it in terms of like the cards that we drew, and then looking at outcomes as an ordered pair and determining your events that way.